Hello, everyone. Good morning, good afternoon, and good evening. I'm saying this because I know you're physically everywhere in the world. Well, this year the conference is so special because of the COVID-19 outbreak. I want to take this opportunity to thank you for having me here today, and I wish you and your family stay healthy and safe. Well, today I want to talk a little bit about the future of flexible electronics. So let me share the presentation here first. Give me a second. Okay, I hope you can see my presentation now. All right. Well, before we go to the details, let's look back to the latest technology history first. As we all know, in 1980s, PC changed the way we work. In 1990s, the internet changed the way we connect. And in 2000, especially in 2007, when Apple launched the first iPhone, the mobile internet changed the way we communicate. Now, everyone is asking what's going to be the future. Well, people have been talking about IoT for a long time, and I believe that could be the future too. In IoT, there are several major infrastructure areas. In my opinion, it's perception, computation, and communication. So everyone knows AI is going to be the platform for computation. 5G is going to be the platform for communication. But what is the platform technology for perception? Human-machine interface, or we call it HMI. So among all of the perception systems, vision is the most direct way for people to experience and interact with the world. And that's why our community here today in the Optical Society matters so much. Well, actually, people have been exploring the best visual experience and the human-machine interfaces all the time. And the progress of display technology is a good example to understand this. Well, in the last century, the CRT or cathode ray tube technology is one of the most important technologies. It's heavy, bulky, so later it was replaced by the LCD technologies or liquid crystal display technology, which is lighter and thinner. Today, there's still many use scenarios. Well, in the last 2 decades, another technology called AMOLED display, or sometimes called AMOLED display, which is thinner, lighter, and even curved, start to be used in TVs and smartphones. But they are still rigid. Although sometimes a curved AMOLED display, in the smartphone industry is called a flexible display, but it's not bendable, foldable, or rollable yet. It's not the real flexible. So what is next? We believe it will be the displays that can be repeatedly flexible, foldable, or even rollable with a lot better thickness, lightweight portability, and reliability. We call this fully flexible display. And we believe this could be the next big wave and the next generation human-machine interface. So let's take a look at the mobile phone industry as an example to understand how important the human-machine interface could be. In the 1990s, the feature phone with a small LCD display and the dial pads made huge success on the market. Like Nokia, Motorola, the phones were almost everywhere. Well, in 2007, when the iPhone was a touchscreen and a bigger display came to the market, it changed the whole phone industry because the new interface changed not only the hardware, but also the software, the operating system, the business model, and the entire ecosystem. So that's what we call the mobile internet age. Today, we're still using many different electronics at the same time, like smartphones, pad, tablet, PC, TV, and some are for portability and some are for large screen visual experience. Traditional technologies are not able to solve the conflict of these demands. If any new technologies can combine both the portability and the large screen visual experience together, it could change the way we design and use electronics again. Fully flexible display is this kind of a new technology. And that's why Royole launched the first foldable smartphone back to 2018 with its fully flexible display. This foldable smartphone is not a marginal improvement over the traditional smartphone space. Fully flexible display is a brand new way of human-machine interface that can again enable innovations of hardware, software, operating system, and business model, and provide unprecedented user experiences for the mobile device. Royole has been pursuing the solution for the fully flexible displays that can solve the conflict between portability and the large screen visual experience since day one. Just in case you don't know much about Royole, let me give you a brief introduction here. So we have been thinking about the flexible display idea back to our school days in Stanford in 2006, actually before the first smartphone iPhone was launched. And in 2012, we came up with a new idea of fully flexible display, and we decided to found our company called Royole to work on that. And the mission was to develop flexible technologies to change the way we experience and interact with the world. In 2014, we introduced the thinnest fully flexible display with a thickness of 0.01 millimeter. And also we started the mass production of the fully flexible sensors. So later we started the construction of our own production facility for the fully flexible display with a total investment of about $1.7 billion. And it successfully went into mass production in 2018. This production line actually became the first one dedicated to the mass production of fully flexible displays and foldable displays, not just for traditional curved displays. And in the same year, we also launched the first foldable smartphone in the industry, and it's called FlexPi. Earlier this year, we introduced the upgraded foldable smartphone FlexPi 2 based on Royole's latest fully flexible display. And we also work with many leading industry partners like Airbus, Louis Vuitton, China Mobile, ZTE to provide the flexible solutions for many different innovative applications. The main technologies in Royole now include fully flexible displays, fully flexible sensors, and also the Flexible Plus platform. So we design and produce our own consumer devices like foldable smartphones and the smart writing pads based on Royole's flexible technologies. We also provide flexible technology solutions to business clients globally. Well, just to give you a brief idea of how Royole's fully flexible display look like, here's a video of the display produced from our mass production line. And you can see it's super thin, lightweight, fully flexible, and also it's very high resolution. So what we are talking about today are not just concepts, they are real technologies and the products on the mass production already. Here is our international campus for the fully flexible displays based in Shenzhen with the mass production facility here. For fully flexible display module, there are hundreds of functional layers that add up to the end module. And traditionally, design requirements are much simpler, for example, like for adhesives. For fully flexible display module, there are many design considerations and trade-offs that have to be balanced simultaneously in order to make sure the overall performance is decent in every aspect. So the module material stack up now consists of several key layers. For the cover film, we require high-yield strain-based film with a hard coating layer to deliver critical surface properties. Such requirements on mechanical and thermal properties mean the optical properties have to be compensated. For the touch, we can adopt multiple architectures to deliver excellent touch performance while keeping the flexibility. For the adhesives, they serve as strain buffer layer to eliminate the accumulation of strain over the structures. To make the fully flexible display useful, we also have to use ultra-thin polarizers. Ultra-thin polarizers see a lot of progress in recent years. Well, the traditional approach has to be completely changed. For the display layer itself, it includes the driving backplane, the OLED front plane, and also encapsulation. Flexible thin film encapsulation and process is not easy for the flexible displays. And it's very important to maintain good light extraction and local string optimization. All these new requirements make the module design, optical design, a lot more challenging than before. To fully utilize the foldable form factor, the product designers, they want to use fully flexible displays in larger size. That brings new challenges over optical inspection capabilities and the corresponding compensation scheme. Now, it's required to have sub-pixel level RGB brightness sensing and correction to maintain the good brightness uniformity as well as the color accuracy across the panel. One example of the new compensation schemes is on the IR drop, which could affect the gamma performance a lot. And the system level approach has to be adopted for both the global and the local type of corrections to deliver consistent performance. From the user experience point of view, the new fully flexible display form factors change some particular specifications. For example, now it's expected that users will look at the screen at a variety of different angles when holding and folding the device. And it's more important than ever before, to care not only the uniformity of the front-facing luminance, but also the angular performance of the display in terms of the brightness as well as the color accuracy. A fully flexible display has to deliver less brightness decay at a given angle, and also keep the color balance the same with that on a normal instant angle. In other words, it has to be very small JNCD, just a noticeable color difference. On the other hand, as we mentioned before, the engineering for this becomes more complicated since the module design is to accommodate optical, mechanical, and electrical considerations all at the same time. As a result, it takes comprehensive optimizations. On the emission device level, for example, the cavity design of the OLED devices need to be tuned very carefully while keeping the design of the other properties competitive. On the process control side, we need to design decent light extraction structures like pixel defining layers, thin film encapsulation to give proper profiles or thickness control within the design window. On the module film level, for example, the angular dependence of the thin coating polarizer has to be properly compensated. All these factors combined are required to deliver the optimal viewing angle performance. So the end result is illustrated here on the figure. And our latest fully flexible display, we call the third generation Cicada Win, actually performs much better than both traditional high-end displays and also the other foldable displays are now on the market. For the flexible touch sensor, the integration is also a challenge for the fully flexible displays. We have to maintain excellent flexibility, high sensitivity, and high transparency at the same time. And traditional brittle materials on the touch sensor can just not work. It's a lot more challenging than traditional touch panels. We can use different architectures in the short and midterm, depending on the product specifications. Our solution relies on alternative flexible transparent conductive film, what we call TCF, and the corresponding process technology. We have been working on that since very early on, and it has delivered excellent yield and performance by now in the company. Meanwhile, other integrated touch architectures are being developed, including on-cell and even eventually in-cell touch. So an integration with other optically functional layers is certainly a trend. Plus, due to the large panel loading, we have also developed a detailed simulation framework to study the pattern, the module stack up, and the driving circuits to find optimal solutions. The OLED device engineering also requires major change in the directions of optimization for the fully flexible displays. And it's well known that device engineering is always a trade-off between efficiency, color performance, and lifetime. And traditionally, when the major differentiation factor between OLED and the other display technologies, color performance. And OLED device, delivers deep blue, deep red in colors. However, as you can see in the right figure, for each set of emission material, there's always an optimal efficiency at a given color index. So typically, if you push the color index into the extreme, it means we have to sacrifice on peak efficiency. For the foldable display, efficiency becomes more critical as shown in the top left figure, where the overall panel power consumption largely depends on the individual OLED device's current efficiency. And of course, at the same time, there's a trade-off between the lifetime and the efficiency as well, which can be improved by the fundamental materials or device stacking design. In short, for the fully flexible display applications, OLED device engineering considerations will change significantly from the traditional OLED displays. Beyond the optical and electrical design challenges for the fully flexible displays, mechanical design is another big issue. From the user experience point of view, we don't want to see the display malfunction, misplacement, the folding crease, or even film crack. All of this is terrible in the foldable devices, and they actually did happen a lot in some foldable smartphones on the market. So our team has been working early on in a new way to tackle those problems, a few years ago by building a software program called a Smart Mechanical Simulation Model. Well, to give you a couple of examples, we can utilize the mechanical simulation model to calculate the amount of strings in each layer of the module stack at different bending radius. And this helps us decide the bendability of a design module. The bottom right figure shows the simulation result of the module, in consideration of the viscoelastic models for the adhesive layers. When folded and fully relaxed, you can clearly see the slippage effect. When the structure is unfolded, it has to, it has a tendency to, maintain the shape as a stress strain at certain response time. So after a certain time period, the structure becomes, fully relaxed. All of those effects can be accurately captured in our model, and in turn, guiding the mechanical design of our module. So as you could see, to make the fully flexible display or foldable display available for mass production and market applications, it just took a lot of efforts because there's so many technical challenges along the way. When we started this journey in Royole, to find the solution for the fully flexible display technologies, there was truly no existing product on the market from any company yet. Also, there's no mature technologies for reference at all. So our team, started from scratch to overcome a series of problems across the nanomaterials development, flexible, TFT device design, and OLED device engineering, flexible driving circuit design, process development, module design, film stacking design, and even production equipment customization. In the past few years, our team successfully developed it's called ultra low temperature non-silicon semiconductor process, or ULT and SSP technologies for the fully flexible displays, and turned it into mass production in our own production facility in Shenzhen in 2018. Not just for traditional, LTPS or polysilicon-based curved display, which sometimes is also called a flexible display. So our facility is actually the first mass production line dedicated to fully flexible display or foldable display in the industry. So here shows a few videos of different testing on Royole's latest fully flexible display products. The commonly seen surface smoothness and layer peeling issue is no longer an issue for the third generation Cicada Win fully flexible display. And it also, survives very well, after stringent bending test, the scratch test, the twist test, stretch test, the drop test, and so on. And it's truly impressive performance and reliability. Well, as you can see here from multi-dimensional bending test, the third generation Cicada Win fully flexible display can easily stand over 200,000 times of bending, and the minimum bending radius could be down to 1 millimeter. So we have done a lot of testing from the material layer, from the module, and from the end product. Like we just mentioned, the latest fully flexible display it's mirror-like smoothness, and it's important for making a real good-looking foldable smartphone. And also the optical performance in terms of the brightness, contrast ratio, response time, color performance, color shift, and the brightness decay in a given viewing angle, all truly outstanding. So these technologies are all in mass production and have been used in different products, including the latest foldable smartphones. Well, as an emerging technology, flexible electronics, especially the fully flexible displays and the flexible sensors, will enable many new exciting products and applications across different industries, and will transform the way people experience and interact with the world. So, according to the latest report from Frost and Sullivan, the global market of flexible electronics is expected to reach over $300 billion by 2025. And the smartphone industry could be, one of the major driving force. Well, just to give you a brief idea of what we have been working on in Royole now, based on the proprietary ULT and SSP technologies and the fully flexible displays and the sensors production capabilities, our team has implemented a flexible plus platform integrated with operating system, software, hardware, and to provide the flexible plus solutions, to clients in 6 major industries already, including like smartphone, smart mobile devices, smart transportation, media entertainment, office, education, smart home, and office, and sports and fashion. Our foldable smartphone, the Flex Pi, is one of the major applications based on the flexible solutions. Well, Flex Pi 1 was announced in October 2018, and that actually was the first foldable smartphone brought to the global market. And Flex Pi 2 was just announced in March this year. So here's a video clip of the product demo of the product launch conference. So compared to Flex Pi 1, it's a lot thinner, lighter. And the new proprietary 3SP without the gap, which makes the new foldable smartphone a perfect combination of portability and the large screen visual experience. And it will be shipped onto the market in next quarter. Please stay tuned. Well, flexible displays could be everywhere. I mean, currently we're serving over 500 business clients globally for innovative applications. Here, let's take a look at a few examples. Not only the smartphone, but also like in fashion industry. We partnered with the well-known fashion brand Louis Vuitton, to integrate our flexible displays in a handbag like this. So you can, personalize the content anytime, anywhere, just by smartphone apps. It's really cool and exciting. It's a great example of how you can, combine the tech and art together, right? Fully flexible displays like Cicada Win, it's thin, it's lightweight, it's flexible, and it's high resolution, so can be placed in different curved surfaces, and while reducing the weight from traditional displays. And for airplanes, this could be very useful in saving space and fuel cost. So we partnered with Airbus, to use Royole's flexible technologies and create a new user experience for the flight travelers. This is very important in industrial applications for the fully flexible displays. If you travel in Shenzhen Airport, or if you went to our booth at CES this January in Las Vegas, you probably have seen this before. Our team built a new kind of tree with hundreds or even thousands of leaves, all made of fully flexible displays. And you can actually easily change the high resolution image or video content by wireless connection or from your smartphone. So it's a new way of advertising too, you know. It's very interesting. So flexible displays, you know, just open the possibilities for many other things. We partnered with a well-known liquor brand in China. It's called Luzhou Laojiao, to integrate our fully flexible displays into the liquor bottle. You can basically display any content you want, you know, on the bottle. So it's a brand new way of advertising and packaging too. We also partnered with the well-known sportswear company Li Ning to design a brand new retail displays, while, you know, with the fully flexible displays. And also we worked with the audio company CLEO in the United States, you know, to integrate the fully flexible displays and fully flexible sensors into the smart speaker. The product is called Mirage. And this product was announced at the CES 2020 in January and will be sold in US and Europe by CLEO very soon. And the unique design here is you can keep the 360-degree surrounding sound and the elegance of the high-resolution flexible displays together. And they also support Amazon Alexa voice control. So it's truly a new smart speaker. Well, here are just a few examples of how different the industries can use the flexible technologies to change the way we design products and provide unprecedented user experience. There are many others, you know, and still a lot more new ideas coming. Back to our, you know, beginning discussion on the technology leap forward in the history. I mean, the IoT future will rely on several major infrastructure areas, mainly perception, computation, and communication. In AI, it's going to be the next generation platform technology for computation. 5G is the next generation platform technology for communication. And we believe the flexible human-machine interface could be the next generation platform technology for perception. So with this, I want to conclude my talk and thank you very much for your time and attention today.